Lesson 1. Angular measures in degrees and radians. Rotation angles in standard position. Angles can be measured in degrees where 360 degrees completes one full rotation. A rotation angle is formed by rotating from an initial arm up to a terminal arm, which is where you end, and then the angle in between those two arms is your angle theta. A positive angle results from a counterclockwise rotation. So if we make 0 degrees the far right, starting from here, if you go up and then towards the left, you reach 90 degrees. And then if you go a little bit further, you reach 180 degrees. A little bit further, you go 270 degrees, and then all the way around completes a 360-degree rotation. A negative angle results from a clockwise rotation. So again, we're going to start from 0 degrees. However, now we're going to be going down and then towards the left. So instead of having this 270 here, I'm going to make this negative 90 degrees. And if you go halfway, that's going to be negative 180 degrees. If you go 3/4 of the way, I'm going to change this 90 degrees into a negative 270 degrees. And making one full rotation means that you've traveled negative 360 degrees. Co-terminal angles. Angles in standard position with the same terminal arm are what we call co-terminal angles. The principal angle of a set of co-terminal angles is the smallest positive rotation angle with the same terminal arm. The principal angle is always in between 0 and 360 degrees. So let's consider 130 degrees and 490 degrees. So if I wanted to draw 130 degrees, I'm going to start with my initial arm at 0 degrees. And then 130 is going to land somewhere in between 90 and 180. So let's draw my terminal arm here. So the angle in between the initial arm and the terminal arm, let's say that that is 130 degrees. Now, if I want to draw 490 degrees, one full rotation represents 360 degrees. So if I take 490 degrees minus 360 degrees, I get 130 degrees. So after I make one full rotation from my initial arm, that covers 360 degrees. But now I need to travel an extra 130 degrees to reach my terminal arm. So after that one full rotation, I'm going to go a little bit extra. And then my terminal arm is going to land right around here. If you compare the two angles, you'll see that you have the exact same terminal arm. So that means that 130 degrees and 490 degrees, because they end in the same spot, that means that they have the same terminal arm. Now, the 130 degrees, that is going to act as our principal angle because it is the smallest positive rotation angle that has the exact same terminal arm as 490 degrees. Example 1. Determine the measures of all angles in standard position that are in between negative 1000 degrees and 1000 degrees that are co-terminal with 150 degrees. So the first thing I'm going to do is draw 150. So my initial arm is going to start at 0. And 150 degrees should land somewhere in between 90 and 180. So let's say the terminal arm lands around here. So this would be our principal angle of 150 degrees. Now, if I want to find angles that are co-terminal, meaning that they land in the exact same spot, what I can do is start from that 150, and let's find angles on the negative side. So I'll just take 150, and then from there, I'm going to go backwards 360 degrees. So what I'm essentially doing is taking 150 degrees and then subtracting 360 degrees. That would result in an angle of negative 210 degrees. So I would end up with the exact same terminal arm, but just a different angle. I can go a bit further. So if I go another rotation backwards, I'm just taking negative 210 and then subtracting another 360 degrees, and that would land us at negative 570 degrees. And then from there, I can just go negative 570, do the same thing, subtract another 360, and that would give me an angle of negative 930 degrees. Now, I'm not going to subtract another rotation because then we'll go over that negative 1000 degrees. So let's go and find our positive angles that are co-terminal with 150. So instead of going backwards, If I started at 150 and then I went forwards, meaning I'm going counterclockwise, I'm just adding 360 degrees to that 150. So on the positive side, I would take 150 degrees, add 360 degrees, which would give me an angle of 510 degrees. And then I can add another rotation. So I'll start with 510, add another 360, and that would land me at 870 degrees. And I'm going to stop there as well because we don't want to go over that 1000 degrees. So negative 210, negative 570, negative 930, 510, 870 are all coterminal angles with 150 degrees that fall in between negative 1000 degrees and positive 1000 degrees. Now, essentially all we're doing is either adding or subtracting 360 degrees. So what we can do is just write a generic expression to represent all coterminal angles. So all you have to do from there is just take your principal angle and then add or subtract 360 degrees, but then we're going to multiply it by a variable that we're going to call n. And what we can do is just state that n can be any whole number. So what we're going to do is, to get our generic expression, is just take our principal angle of 150 degrees and then add or subtract 360 degrees times n, where n just happens to be a whole number. And this is going to represent all possible coterminal angles. A reference angle is the acute angle. Acute meaning that you have an angle that's in between 0 degrees and 90 degrees. It's always going to be the angle formed in between the terminal arm and our x-axis. So for example number 2, we want to sketch the rotation angle and then state its reference angle for each of the following. So for A, I've got 243 degrees. So let's just start by drawing the rotation angle. So I'll have my initial arm at 0 degrees. 240 is going to land in between 180 and 270. So let's say our terminal arm is right around here. So the rotation angle goes from 0 all the way up to our terminal arm. That's going to act as 243 degrees. Now, if I want to find the reference angle, it's always got to be the angle that is closest to the x-axis. So in this case, the closest x-axis that our terminal arm is closest to is 180 degrees. So if I want to figure out what the reference angle is in between the x-axis and our terminal arm, all I would have to do is take our angle of 243 degrees and subtract 180. And then the difference between those two angles is 63 degrees, which means that our reference angle is 63. Now for negative 337 degrees, because it's a negative angle, I'm going to change all of my angles. So I'll still have 0 on the far right, but that's 270 is going to change into a negative 90 degrees. And then the 180 will turn into a negative 180. The 90 degrees up here will turn into negative 270. And going all the way around is going to be negative 360 degrees. So if I want to travel negative 337 degrees, that's going to be our initial arm starting at 0 degrees. And then rotating down and then towards the left until we get to about here. So our terminal arm, because it's negative 337 degrees, is going to land in between negative 270 and negative 360. Now, what we want to do is find the reference angle. So it's going to be where our terminal arm is closest to the closest x-axis. So in this case, it's going to be closest to this negative 360 degree angle. So what we're going to do to find our reference angle, and because I'm dealing with negatives, I'm just going to put this inside an absolute value. I'm going to go negative 360 degrees minus negative 337 degrees. On the inside of the absolute value, I'm going to get negative 23 degrees. But then because I'm taking the absolute value, that's going to force me to get a positive answer, which in this case is going to be 23 degrees. So just make sure that your reference angle is always going to be a positive angle in the end. In addition to measuring angles with degrees, we can also use something that we call radian measure. So in the diagram on the right, I've got a circle and I've got a initial arm and a terminal arm. The angle formed between those two arms is our radian measure, but to figure that out, we're going to need what we call the arc length. So the arc length is going to be the edge around the circle between your initial and your terminal arms. So that's going to act as A. Now our radius is the distance from the center of the circle to the edge of the circle. Now our angle theta is just going to be A divided by R. So if I took my arc length, divided it by my radius, that's going to give me an angle, but it's going to be in radians. We can also rearrange that formula and get A is equal to R times theta. Now for some quick equivalence, pi radians is equal to 180 degrees. 2 pi radians is going to be equal to 360 degrees. Now on the left, I've got my angles in degree measure. So I've got my 0 degrees, 90 degrees, 180, 270, and then all the way around is 360. Radian measure starts at 0 radians, which is in the same spot as 0 degrees. And then 180 is equal to pi. So that means that going halfway is going to be pi radians. And then if you go all the way around, that's going to be traveling a full rotation of 2 pi radians. Now, in between, I've got 90 degrees and 270. 90 degrees is the same thing as taking pi, but then just dividing it by 2. And then 270 degrees is going to be the equivalent of 3 pi divided by 2 radians. Example 3. Convert the following angle measures into radians. Give the exact answer and also the value rounded to the nearest hundredth. So the general rule, if you want to go from degrees into radians, is start with your angle in degrees, and then you will multiply it by a ratio of pi over 180. So for 135 degrees, I'm going to multiply it by pi over 180, which will give me the numerators multiplied together, which will just give me 135 degrees times pi up top, and then on the bottom 180 degrees. Now what we want to try and do is turn this into lowest terms. So I'm just going to look for a GCF between 135 and 180. And in this case, you can divide both of those numbers by 45. So I'm going to take 135 degrees divided by 45, take 180 divided by the 45. That will result in a reduced fraction of 3 pi over 4. So this is going to be what we consider an exact solution. And then if I want to convert this into an approximate solution, I'm just taking 3 pi divided by 4 in my calculator, and you're going to get roughly 2.36 radians. So this is just going to be an approximate answer just because we have to round it. But regardless of having exact or approximate, 3 pi by 4 and 2.36 radians would be equivalent to 135 degrees in radians. Let's do the same thing for 240 degrees. So I'll start with my angle of 240, multiply it by that ratio of pi over 180, and then I'm going to end up getting 240 degrees times pi over 180. And we're going to do the same thing. We want to reduce this to lowest terms. So I'm going to find a GCF between 240 and 180. And in this case, they're both divisible by 60. So I'm going to divide 240 by 60, divide 180 by 60, which would reduce it to lowest terms, giving me 4 pi over 3. So that's going to be our exact answer. And if I put 4 pi divided by 3 into my calculator, I'm going to get roughly 4.19 radians. So this will be our approximate answer because we have to round it to the nearest hundredth. So either way, 4 pi over 3 or 4.19 radians is going to be equivalent to 240 degrees, but in radian measure. For example number 4, we're now going to be converting our angles from radians into degrees this time. and we're going to round it to the nearest tenth, and then we'll sketch the angle in standard position as well. So the idea here, if you're going from radians into degrees, is you're going to start with your angle in radians, and you will multiply it by a ratio of 180 degrees over pi this time. So with 5 pi over 6, I'll take our angle in radians, 5 pi over 6, and multiply by 180 degrees over pi. When you multiply 5 pi and 180 together, the new numerator is going to give us 900 degrees times pi. And then on the bottom, multiplying the 6 and the pi together will give us 6 pi. Now, because we have a pi on top and a pi on the bottom, we can cancel those out. And then just to simplify, if I took 900 degrees and divided it by 6, I ended up with 150 degrees. Now, to draw that in standard position, you're going to start by drawing your initial arm at 0, and then 150 degrees will land in between 90 degrees and 180 degrees. So let's say it lands right around here. So if you're measuring in degrees, from our initial arm to our terminal arm, that'll be 150 degrees. But it would be the exact same distance if you're measuring in radians of 5 pi over 6. Now for negative 12 pi over 11, we'll start with that negative 12 pi divided by 11, and we'll multiply it by the ratio of 180 degrees over pi. Again, multiply your numerators together. So on top, negative 12 pi times 180 is going to give us negative 2,160 degrees. And then on the bottom, 11 times pi is 11 pi. And it's negative 2,160 pi on top divided by 11 pi. So we're going to cancel out these pi's. And then negative 2160 divided by 11 is going to give us roughly negative 196.4 degrees. So if I want to draw that on my graph, 0 degrees would be on my far right. Because we're going negative, I'm going to put negative 90 degrees down here, negative 180 on the other side, and then negative 270 on top, and negative 360 all the way around. So negative 196.4 is going to be roughly around here. So my initial arm is at 0, and I'm going clockwise, so I'm going down and then towards the left. So this would be an angle of negative 196.4 degrees, but in radians, it would be equivalent to negative 12 pi over 11. Example 5. In each of the following, determine one positive and one negative coterminal angle, and then for part 2, write an expression that represents all coterminal angles. So for A, I've got 4 pi over 3. What I want to do is draw the terminal arm first. Now there's a couple ways to do this. For method A, what you could do is take that 4 pi over 3 and then convert this into degrees. So if I multiply by 180 degrees over pi, 4 pi times 180 on top is going to give us 720 degrees times pi. And the bottom is going to be 3 times pi, which is 3 pi. The pi's will cancel each other out, and 720 degrees divided by 3 gives us 240 degrees. So this is just going to help us figure out where our terminal arm is. So 0 degrees is going to start here on the far right, and then here I've got 90, this is 180, this is 270, and all the way around is 360. Okay, so 240 degrees is going to land somewhere in between 180 and 270. So that's my terminal arm, and here's my initial arm starting at 0. So the initial arm going up to the terminal arm, that's going to represent an angle of 4 pi over 3 radians. So that's the first way, is just turning it into degrees. The second way of doing it what I do is I look at the denominator. So in this case, I've got a 3 in the denominator, which means that in the top portion of my grid, I'm going to try to divide this into 3 even sections. Okay, so I've got section 1, section 2, and then section 3. And then I can divide the bottom section into 3 equal sections as well. So let's say that's the first section, This is the second section. So then this is going to create sections 4, 5, and 6. So I want to travel 4 pi over 3. So what I do is I travel each of these sections until I get to 4. So I go 1 section, 2 sections, 3 sections, and then 4 sections. And then where I end up, that is going to be where I draw my terminal arm. So if I erase all these other lines, this is another way of drawing your terminal arm of 4 pi over 3. Now, to figure out my positive and my negative coterminal angles, what I'll do is I'll start with my principal angle of 4 pi over 3. And if I want to get a positive coterminal angle, what I'll do is I'll just go one full rotation around until I reach the same terminal arm, which means that all I'm doing is I'm adding a full rotation of 2 pi. Now, if I want to add these together, let's pretend that the 2 pi is just over 1. So before adding fractions together, I need a common denominator. So in this case, common denominator between 3 and 1 is 3. So I'll just multiply the second fraction on top and bottom by 3, which will end up giving me 4 pi over 3 plus 6 pi over 3. And if I add those guys together, 4 pi plus 6 pi gives me 10 pi over a denominator of 3. So 10 pi over 3 is going to be my positive coterminal angle. If I want to find a negative coterminal angle, I'll start at my principal arm, but this time I'm going backwards. I'm going to go up and then around, which means that I'm just essentially taking 4 pi over 3 and subtracting 2 pi. And again, we can treat that as 2 pi over 1. So if I want to subtract these fractions, I need a common denominator. Again, it's still going to be 3. So I'll multiply the top and bottom by 3. And I get 4 pi over 3 minus 6 pi over 3, which will give me a negative coterminal angle of negative 2 pi over 3. Now, for the second part, if I want to write an expression that represents all coterminal angles, all I need to do is start with my principal angle of 4 pi over 3, and you're either just adding or subtracting 2 pi times n, where n happens to be a whole number. So this is just going to be a general expression that represents all coterminal angles. Now for b, I've got negative 11 pi over 6. Now to draw this for my terminal angle, I'll look at the denominator again. So because my denominator is 6, what I'm going to do is I'm going to split my top region of my grid into 6 equal parts as best as I can. So let's say this is 1, that's 2 sections, this is 3 sections, and then 4, and then 5, and then 6. So this is 1, 2, 3, 4, 5, and then 6. And I'll do the same thing on the bottom. I'm going to try my best to divide this into 6 equal parts. So 1, 2, 3, 4, 5, and then this is 6. So if I continue counting, this will be 7, this will be 8, this will be 9, 10, 11, and 12. Now, we're also going in the negative direction. So if I have a negative 11 pi over 6, I'm going to renumber these. So this would be 1, so negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, and negative 11. So this purple line right here, this is going to be my terminal arm. So if I erase all of this other stuff, I have now drawn my terminal arm of negative 11 pi over 6. So I started from 0, and if you're going in the negative direction, you're going down and then towards the left. So that's going to be my terminal arm. Now, what I want to do is draw a coterminal angle. So from where I ended, if I want a positive coterminal angle, what I'll do is I'll just add 2 pi. to get to the exact same terminal arm. So I would start with negative 11 pi over 6, and then I would add 2 pi. And again, treat that as a 2 pi over 1 so that you can add these two fractions together. I'll need a common denominator. In this case, it's going to be 6, so I'll multiply the 2 pi over 1 on top and bottom by 6, which gives me negative 11 pi over 6 plus 12 pi over 6, which results in a positive coterminal angle of pi divided by 6. And if I want to find a negative coterminal angle, what I'll do is I'll start from my my terminal arm of negative 11 pi over 6, and this time I'm going the other direction, so I'm going to essentially be subtracting 2 pi. So I would go negative 11 pi over 6 minus 2 pi, and again, I'll put that over 1. If I want to subtract these two fractions, I need a common denominator. So again, I'm just going to multiply the top and the bottom of 2 pi over 1 by 6, which gives me negative 11 pi minus 12 pi. Both of these are over 6. And if I subtract these, I would end up getting negative 23 pi over 6. So that's going to be my negative coterminal angle. And then just to write a generic expression to represent all coterminal angles, start with your principal angle of negative 11 pi over 6. And all you're doing is just tacking on plus or minus 2 pi times n, where n is a whole number. This is the expression that's going to represent all coterminal angles. For example number 6, we're going to be using our arc length formula, which is A is equal to R times theta. So we want to find the arc length of a circle that has a diameter of 20 centimeters, and the central angle is 150 degrees. So just to visualize, let's say 0 degrees is going to be on the far right here. If I draw a line from the center of the circle to that dot I just made, that's going to be my initial arm. And then my terminal arm needs to go up to 150 degrees. So let's say it's right around here. Okay, so our central angle is the distance between our initial arm and our terminal arm, which is 150 degrees. Now the arc length, what we're trying to find, is the edge of the circle in between our initial arm and our terminal arm. So this is going to be the A that we're looking for. In this formula, R represents the radius of the circle. So to find the radius, we're given the diameter of 20 centimeters. So the diameter is the distance from one edge of the circle to the other. So that entire distance would be 20. If I want to figure out the radius, which is just the center to the edge of the circle, I just need to take 20 and then divide it by 2. So then our radius is going to be equal to 10 centimeters. Now the angle in this formula, that theta has to be measured in radians. So right now we're given 150 degrees. So what we have to do first is convert this 150 into radians. So all we'll have to do is multiply it by a ratio of pi over 180. And on top, we're going to get 150 times pi, which is 150 pi. And then on the bottom is just 180. If I reduce this down to lowest terms, I just need to divide 150 and 180 by a common factor of 30, which would result in a radian measure of 5 pi over 6. So our angle theta is going to be 5 pi over 6, and our radius is equal to 10 centimeters. So the arc length is going to be equal to 10 centimeters times 5 pi over 6. We're just going to type in the right side into our calculator with the brackets around the 5 pi over 6, and that would result in a decimal of 26.1799 and so on. But we want to round to the nearest tenth. So if I round this to one decimal place, it's going to be an arc length of 26.2, and our radius and our diameter are measured in centimeters, so our arc length is also going to be measured in centimeters. Example 7. A pendulum 30 centimeters long swings through an arc of 45 centimeters. Through what angle does the pendulum swing? So that 30 centimeters long represents the length of a string with the pendulum below it. So this is 30. And the arc is 45 centimeters. So that means that when we swing this pendulum, the furthest it goes on the left is over here. And then the furthest it goes on the right, let's say it's right over here. So the arc that's going to be traced out by that pendulum is going to be this blue line. So this is going to represent that outer edge of that circle. So let's say that that is 45 centimeters. So if this is going to be the arc length, we can treat the 30 centimeters as our radius. Now what we're trying to find is the angle that's in between the furthest it swings on the right and the furthest it swings on the left. So our formula is A is equal to R times theta. But since I'm trying to solve for theta, what I can do is I can divide both sides by R. And that's going to give me a formula to figure out what theta is. So theta is going to be equal to the arc length divided by the radius. Now we're given both of those. Arc length is 45 and the radius is 30. So all I need to do is take 45 divided by 30, which gives me 1.5. Now this is going to be our angle, but it's measured in radians. We want to answer our angle in degrees. So all we have to do now is take 1.5 radians, and then to convert it into degrees, we're just going to multiply by a ratio of 180 over pi. On top, 1.5 times 180 is going to give us 270 degrees divided by pi. Now, I'm just going to type 270 divided by pi in my calculator, and that's going to give us roughly 85.9 degrees in degree measure.